Welcome to this explainer. Today, we're totally flipping the script on one of the world's most famous ancient sites. We're going to dive right in and look at the Nazca Lines, not as some kind of mystical art project, but as a purely data-driven engineering problem. We're stepping away from the standard myths and looking at the raw physical data to see if we've basically been misunderstanding the Nazca Plateau this entire time.
I mean, think about it. For decades, we've looked at these massive shapes and just assumed, well, they must be giant calendars or drawings for the gods. But honestly, that just doesn't explain the literal miles of backbreaking labor it took to build them. We are talking about hundreds of huge, precise shapes carved into one of the absolute driest places on Earth. The sheer effort required to pull this off demands a way better explanation than just, ancient artwork.
So here's our roadmap for today. First, the Nazca Line mystery. 2, a new geophysical solution. 3, system mechanics. 4, functional geometry. 5, field tests. And finally, number 6, the ultimate question.
All right, Section 1, the Nazca Line mystery and the limits of symbolic explanations. Here is the massive paradigm shift we are talking about today. We are pivoting completely away from that old view of ritual pathways and star maps and moving to a wild new idea. What if these lines were actually functional, working machinery? Their primary purpose wasn't just to look pretty from the sky, they were engineered as an operational system designed to physically interact with the environment.
Which brings us to Section 2, a new geophysical solution driven by THD research.
This whole new perspective comes from triune harmonic dynamics, or THD, research author Kevin L. Brown. As a researcher, inventor, and author, he brings a totally revolutionary idea to the table. He calls the lines a lithic-capacitance interface. Now, I know that sounds super technical, but it's really an 8th grade concept. It basically means the desert is a giant passive circuit board. By peeling away the dark, iron-rich surface rocks to expose the lighter dirt, the builders essentially stripped the rubber off a wire to expose the conductive layer underneath. And by doing this on a massive scale, they created a network that changes how electricity and heat flow across the entire desert.
Moving to Section 3, system mechanics, and how this 3-layer engine actually works.
So to understand this massive circuit board, you have to look at the whole environment. The system relies on 3 interactive layers working together. You've got the exposed surface we just talked about. You've got the charged atmospheric layer above it, which changes with the sun and humidity. And then below ground, you have the subsurface layer, where tectonic stress from shifting plates actually releases electrical charges. The surface lines sit right in the middle of all this, basically acting as a bridge to manage energy between the sky above and the shifting rocks below.
Now for Section 4, functional geometry, where we see that these shapes actually have a purpose.
If this desert is a machine, then the shapes are its parts. The geometry isn't just aesthetic at all. Long straight lines act as conductive wires to direct energy. Those massive trapezoids, they serve as huge grounding pads to collect it. And the spirals act to concentrate or focus that energy. For example, think of that famous monkey drawing with the huge spiral tail. Under this THD research model, that spiral is a natural concentrator for energy flow. It makes it a highly functional part of the machine, not just a cute drawing in the dirt.
All right, Section 5, field tests, and how we put this hypothesis to the test. Look, any good engineering theory absolutely has to be testable. That's what separates real science from just guessing. If this desert really is a passive interface, we should be able to go out there right now and measure specific physical differences. We should see altered electrical conductivity in the lines. We should measure definite temperature shifts when the hot sun hits the clear dirt versus the dark rocks. We should even find elevated moisture hiding right under these specific paths.
But here's the best part, the falsification criteria. How do we prove this wrong? Well, if researchers go out there and those cleared lines behave exactly the same as a random patch of dirt just 3 feet away, the entire capacitance model fails completely. If there's no difference in heat, no difference in ground currents, and no connection to the earthquake fault lines beneath them, the theory is dead. And honestly, that is a wonderfully clear, strict standard for modern research.
So this is the exact 3-step game plan researchers need to take to the field. 1. Compare the cleared lines to the dark rocks for conductivity and temperature. 2. Measure that underground moisture. And 3. Map the lines against known earthquake fault zones. It is a completely data-driven roadmap to solving a mystery that's literally 2,000 years old. Finally, Section 6, the ultimate question, and how we might be redefining ancient engineering altogether.
I absolutely love this quote from Kevin L. Brown because it perfectly sums up our objective here. He says, the Nazca Lines are best modeled first as passive geophysical infrastructure and only secondarily as symbolic landscape art. It doesn't mean the lines had zero cultural meaning to the people who built them, but it means they were meaningful because they actually worked. They were machines first and symbols second.
Which leaves us with a truly fascinating question to end on. If future tests prove this right, if ancient humans were fully capable of engineering a functional, landscape-scale circuit board out of nothing but dirt and stone, well, what else did we get wrong? How many other ancient art projects sitting around the globe are actually advanced, unrecognized technologies just hiding in plain sight? Something to really chew on. Thanks for watching, and I'll see you in the next explainer.